for example, the nuclear oscillation problem and others. So it's important in order to improve our understanding of the Earth's climate and weather relation with controversial problems of signature of solar activity, variability in meteorological parameters, Earth atmosphere, chemistry, and long-term trend in Earth's climate. So this space weather and space climate have a big impact on space technology. Therefore, we need to study space climate and space weather. So underneath climate, space climatology of the atmospheric total electron content below ርዕስ atmospheric TEC ነው የሚያጠኑ total electron content ግን long term data ወስዶ ሲያጠኑ ነው climatology የምንለው። otherwise weather ካልነው ደግሞ short term መሆኑን ነው። እነዚህ ሁለቱም ግን they do have a big impact on space technology. Specifically those regions located near to the polars or high latitude are highly affected by space climate and space weather. Okay, therefore, but when these phenomena, space weather and space climate, are extreme enough, there are different mechanisms that make them to propagate down to the middle and low latitude as well as the equator where we are living. And then in that case, we need to study our region in terms of space weather, in terms of space weather. ለምሳሌ ብዙ ጊዜ ስኮላርስ ክሌም የሚያደርጉት ስፔስ ዌዘር ኢኳተርና ሎ ላቲቲዩድ ላይ ኢምፓክት የለውም የሚል ሪፖርት የሚጽፋሉ። ግን ዳታው ወስዳችሁ ስታይ you can see how space weather are affecting our region. Yes. Hello, are you with me? Not so. Okay, so we can say the variabilities or the variations and the periodicity. Okay, periodicity. The solar radiation as main element of space weather varies at a very different time scales. ለምሳሌ variationዎችን due to solar activity and due to solar earth system ብለን variation ማናጠናለን. I think you are familiar with this. For example, if you are studying about the seasonal variation, therefore obviously this is due to the solar earth system. በፀሐይና በመሬት መካከል ባለው arrangement ምክንያት የሚፈጠር መሆኑን ማሰብ አለባችሁ when you talk about solar seasonal variation. The daily variation is also due to that orientation, but solar activities like 27 days solar rotation, 11.2 years solar activity, 20 years, ሌሎችም እነዚያ ቫሪሽኖች they are totally due to solar activity ናቸው። ከእርዝ ጋር የሚያገናኛቸው የለም። ከእርዝ ጋርና ከፀሐይ ጋር ሁለቱን አሬንጅመንቶች አድርገን ስናጠና ግን seasonal variation and daily variation ማለት ይቻላል። For example, when you talk about the seasonal variation, they are related with the seasonal variation of the geomagnetic activity, the variation of outer layer beta electron population due to motions of the earth around the sun and others can be considered, and therefore this kind of variabilities can be considered. When you talk about space radiation environment, basically, as I've said, the radiation are associated with electrons, protons, and ions, the heavy ions. And basically, these ions, protons, and electrons, they are trapped by the Earth's magnetic field. So you can think what will happen to these electron, proton, and ions if our planet do not have magnetic field. መሬታችን magnetic field ባይኖራት ኖሮ እነዚህ ኤሌክትሮኖችና ፕሮቶኖች ምን ይሆኑ ነበር ከፀሐይ መጡት የሚለው ማሰብ እንችላለን. And then you can search for different planets which do not have or which have very weak magnetic field. ፕላኔቶቻችንን በጣም weak የሆነ magnetic field ያላቸው magnetic field የሌላቸው ሚል ፕላኔቶች ካሉ እነዛ እንዴት አድርገው በኤሌክትሮን ፕሮቶንና አዮን እንዴት አፌክትድ እንደሚሆኑ ማየት ይቻላል. So the importance of magnetic field is can be considered in terms of the electron, proton, ion that come from the sun. And then basically, you can see how these trapped radiations or particles can be deposited in the radiation belt, the Van Allen belt. Electrons with this energy range and protons with this energy range can be deposited in this radiation belt, the Van Allen belt. And then this electron, proton, and ion, they can also pass through the solar system. Okay? Like the solar wind, the solar particle, the galactic cosmic rays. እነዚህ በሙሉ እነዚህን ሁሉ ስናጠና ስፔስ ራዲሽን ኢንቫይሮንመንት እያጠናን ነው የምንለው። the radiation belts ስናወራ the solar wind, the solar particle even, the galactic cosmic rays እነዚህ. And then the different missions that I have already talked so far are dedicated for studying the space radiation environment. Now let me to the conclusion of the today's point. It's only today's lecture is only on the space-based observation. Next week we'll see the ground-based observations, and then we'll see how that observations are important. But for the time being, let us conclude our today's talk. So we have seen observation of radiation by the Earth's atmosphere and the need to observe from space. We have also seen features of the Sun-Earth system and the several significant space missions for solar and forest observation were briefly described. We have also seen different observations like coronal mass ejection, magnetic cloud, and others. And basically, this magnetic cloud, coronal mass ejection, and the plasma, they do have effect on the Earth's magnetosphere as well as the ionosphere of the Earth. And then we have also seen, to some extent, the sun has connection as well as the space weather. So that is all about space-based observation that are dedicated for space observations. Okay. So እንግዲህ ትንሽ እንትን ለማድረግ ዛሬ ያየነው space-based observation ለፀሐይን ለኦብዘርቭ ለማድረግ የምንጠቀምባቸው የተለያዩ ሳተላይት ሚሽኖችን ነው ያየናቸው። እኔ ሪቪው አረኳቸው የተወሰኑት ሊሆን ይችላል። ከዚህ በላይ ሳተላይት ሚሽኖች አሉ። ከዚህ በላይ ፀሐይን ለማጥናት ዴዲኬትድ ይሆኑ you can review different literatures, but the very important thing is ወይም ኦብጀክቲቭ ምንድነው? እናንተ አዮኖስፌሪክ ፊዚክስ ስታጠኑ ወይም ማግኔቶስፌሪክ ኢምፓክት ስታጠኑ ከፀሐይ ጋር በተገናኘ የፀሐይን ቢሄቪየር ናይስሊ ዲስክራይብ ካላረጋችሁ በዛ ወቅት በመታጠኑበት ፖይንት ላይ ዲስክራይብ ማድረግ ካልተቻለ የፔፐራችሁ ሻሎ ነው የሚሆነው። Therefore, the intention of this lecture is to show how different missions have been operating for the sake of solar observation. ሶላር ኦብዘርቬሽንን ለመጠቀም ኦብዘርቬሽንን ለማግኘት የተለያዩ ሚሽኖችን ነው ዛሬ ያየነው። እንግዲህ ወርልድ ዋይድ ኮላቦሬሽን ያለው በተለይ ቤዚካሊ ናሳ የአውሮፓን ስፔስ ኤጀንሲ the Japanese, even the Chinese have their own space observation. The solar observation አላችሁ። እነዚህ ሳተላይት በመጠቀም መሬት ፀሐይን ኦብዘርቭ ያደርጋሉ። ወደ ግራውንድ ስንመጣ when you come to the ground ላይ ኦፕሬት የምናደርጋቸው ኢንስትሩመንቶች በሚቀጥለው ማያቸው ሬዳር እና ግሎባል ፖዚሽን ሲስተም በተወሰነ ደረጃ በሚቀጥለው መጣለው። እነዛ የአትሞስፌራችንን ወይንም የአዮኖስፌራችንን ቢሄቪየር የምናጠናባቸው መሳሪያዎች ናቸው። ፀሐይ ላይ ምን ተከሰተ እነዛን በሶላር ኦብዘርቫቶሪስ ቅድም ካየናቸው ከወሰድን በኋላ በደንብ እነዛን ዲስክራይብ ካደረግን በኋላ ወደ መሬት መጥተው እነዛ ፌኖሜናዎች ምን አፌክት አድርጉ የሚለውን ደግሞ we apply GPS and radar, other different satellites. ለምሳሌ ከ2007 ኦፕሬት ሲያደርግ የነበረ ቻምፕ ሳተላይት አለ። ሌሎችም ሳተላይቶች በመጠቀም ግራውንድ ላይ ያለውን ኢፌክት ማጥናት ይቻላል ማለት ነው። ስለዚህ ለእኔ ለዛሬ ይሄን ነው ያለኝ። ምናልባት ሐሳብ ካላችሁ ጥያቄ ካላችሁ ዲስከስ የምናደርግባቸው ፖይንቶች ካላችሁ the time will be for you. You can raise your comments or questions regarding to this space observations for interaction. Okay, Chala is trying to speak. Chala, I don't have any.
Yes, really thank you very much for your nice presentation. Really, I'm very happy to attend such nice presentation. I have some questions on slide number 35. Yeah, on this
Okay.
magnetic field in terms of degree, theta and psi.
Okay.
As you know from different papers, we can explain the variations of solar wind parameters in terms of interplanetary magnetic field, IMF BZ component only. Is it possible to get magnetic field in terms of degree, like theta and psi? Is it possible to get their data directly from
Yes.
Omni or from AC? And then if we used magnetic field in terms of degree, what physics behind they can tell us? For example, interplanetary magnetic field BZ goes to southward direction with a decrement in DST index shows. We can say that the phase of the storm, like main phase, there is also the ionization like that. So is it possible to generate the data or to get the data for magnetic field in terms of theta and psi? Or
Yes,
there is a conversion?
Yeah. Basically, we usually use the IMF BZ to say something about the orientation of the magnetic field, so that we can say it is favorable for the sun and earth's magnetic field reconnection. And that is the usual approach. But still, from the rotation of the magnetic field within the magnetic cloud, we can say something about the condition of the phenomena on the earth, on the sun, I mean. Therefore, I think I've taken this one from that website. I didn't upload this, by the way. I took it from the literature, but I'm 100% sure that you can get the theta and the phi angle, the electron pitch angle distribution, to suggest bidirectional flow or omnidirectional flow of the magnetic field. And this is just to say something about how the magnetic field is varying in terms of its pattern. BZ የሚሰጠን ምንድነው? ብዙ ጊዜ ሳውዝ ዋርድ እና ኖርዝ ዋርድ መሆኑን ያሳየናል የማግኔቲክ ፊልዱ። ይሄኛው ደግሞ ፓተርኑን ወይም ዳይሬክሽኑን within the magnetic cloud እንዴት ፓተርኑ እንዴት እንደተቀየረ ወይንም እንዴት ዩኒፎርም ቫሪዬሽን እንደሌለው you can see, for example, day 50 ላይ day 40 ላይ የማግኔቲክ ፊልድ ኦሪየንቴሽኑ በጣም ቫሪ አድርጓል። ኦሪየንቴሽን አንግሉ ቴታውና ፋዩ ዳውን and ወደዛ እዚህ ክላውዱ ማግኔቲክ ክላውድ ተፈጠረ በተባለው ቀን ላይ ግን day of 15 ዩኒፎርም አይነት አፕሮች ነው ያለውና ያ ዩኒፎርም አፕሮች is a favorable condition for the occurrence of magnetic cloud.